Hello everyone and welcome to today's video. We'll be going over Leetcode problem number 1407, which is top travelers. This is a database problem and we can see that the problem is comprised of two tables. We're given a users table that has the columns ID and name. Then we also have a rides table that has ID, user ID, and distance. Um, and then we see right here there's an explanation. ID is the primary key for this table. User ID is the ID of the user who traveled the distance. So what we can see here is likely that user ID is going to be the same in the rides table as the ID in the users table. So that's just something to keep in mind moving forward because we're likely going to have to interface with both of these tables. So let's look at our prompt. We are supposed to return the result table ordered by traveled distance in descending order. If two or more users traveled the same distance, order them by their name in ascending order. Okay. So first, picking this apart, we'll see we want ordered by traveled distance and descending order. And then we can see on our example that we're given a list of the names as well as their IDs. And then we can see that our assumption was right. All of the user IDs are the same as the IDs in the users table. So we can see the output that they want is the total distance traveled. And how we know that is we can just look at 19, for example. 19 took 2 rides and they returned 450 for user ID 19. And we can see that 19 is Elvis. So that's how they're linking these two tables together. So now let's first get into the problem and let's start with just our simple layout. So we're going to do select from, and then on this one, we're going to have to select from both tables. So we'll likely use a join. And we'll get into that in a moment, but let's just start out with what we're going to return. So first we want the name, and the name is only in the users table. So we want users dot name. And this notation right here, all this says is that you want the name column from the users table. And this is you have to use this kind of notation whenever you have multiple calls. Or if a column name shows up in both tables, like with the ID. So ID is ambiguous because it shows up in both tables. So you would have to declare which table you're pulling from. And it's kind of good just to keep track of where you're at, to do this with all of them if you're going to do it. But in this case, you don't have to, just because name is not an ambiguous column. Then now let's get into our more complex second, which is the traveled distance. So first off, that would just be the sum, because we want the total, as we did here. We did 400 plus 50. So we want the sum of the rides dot distance. And that is just pulling from the rides table and the distance column. So we see here distance and distance, and we're pulling from the rides table, so that's why we did rides.distance. Now, there is something that will happen later in the problem whenever we run this that will need an extra statement, but we'll get there whenever we get there. And then we're going to rename this as traveled distance. So now we can do select from either table since they're both here. For this one, I'm just going to do from users. But it doesn't matter because we're going to end up doing a join anyway. It might just change the type of join you do. So now we're going to go into our join, which is going to be a left join. And the reason we are using a left join, let's see, 1, 2, 3, 4, 7, 13, 9. So we want the travel distance for all of the names in this users table, even if they didn't take any rides. So we see that with Donald here. Donald was returned even though he doesn't show up in the rides table. And that's just going to like limit which type of join you can use. You're going to have to either use a left join or a right join just based on whatever you put here. So whenever you use a left join, it's going to it's going to use all of the IDs that are in the users table because we put users here. If we were to put rides here, we would have to do a right join because we're going to have to declare that later on. Because if not, you'll just get the IDs of users that were in the rides table. And in that case, Donald would be left off. So we're going to do left join rides. And that's just how this kind of notation works. You're just going to put from users and then left join with the other table that you're calling. So we can do left join rides, or you could have flipped these and did from rides, right join users. Either one will work. And then you have to use an on with a join because you're going to say what two columns are the same between these tables where I can compare them. And we're going to do on users dot id. Remember, we have to do this because this column is ambiguous. Equals rides dot users id. User id. So user id, and then that equals rides dot user id. So this is just saying those two columns contain the same information. So the ID from the users table, which is what we said here, is the same thing as the information that's found in the user's ID from the rides table, which is what we stated there. So now we can go into our next part of our statement. So with this sum, we're going to need to tell it what it's going to be summing by. So in this case, we want the distance traveled by each user. So what we're going to do is group by, and then we're going to do rides.userid. So that means it's going to sum for each user ID in the rides table. Rides.userid. So if we were to do this in a different way, it wouldn't sum by the user ID, but we could also do this with users.id. Either way works. And then we're going to order by. And how we're going to order by is going to be given here. So we're going to do travel distance in descending order. So order by. And we're going to do travel distance. And the default is ascending order. So we're going to have to declare descending, which is what we're going to do with the DESC. And then also we have the second condition. If two or more users travel the same distance, order them by their name in ascending order. So we're also going to have to put name. And the way you do order by, it's stacked by priority. So it's going to first order by travel distance. And then if it finds anything that the two values are the same, it's going to go into your next statement in your order by, which is going to be name. So if you were to have another one, you could also stack it here and put another one, but this is going to be it for our purposes. So now this is the basic skeleton of what we're going to need to return everything. There's just going to be one case that we're going to run into that I'm going to show you how to fix. So when we run this, what we see is we get the wrong answer. And that's just because the Donald row is left blank. So we can see that in our output, we didn't assign anything for Donald, but what was expected was to have a 0 there. And that's just going to be one little addition to our code here. So you're going to have to do the if null statement. And you can just stack it right with your sum. So you're going to put this over your sum of rides distance, and it's going to check if sum of rides distance is nothing or is null. You're going to be able to put a value that it's going to return in place of a null. So in place of this blank space, we're going to be able to denote what we want to return. So this is considered a null space, so now we can just put comma 0 because we want to return a 0 instead of a null here. So now if we run this, we'll see that it is accepted, and this will work for all test cases. So now I'm just going to show you a few more little things that we could have left out. So first, name is not ambiguous, so we can leave that off. Distance is not ambiguous, we can leave that off. Users.id, that is ambiguous. User ID, that is not ambiguous. And then user ID again, not ambiguous. So we run this again. Again, it's accepted. And that's just showing you that you don't have to put those things if there's only one column for the tables that you're inputting that have the same name. So if for example, name only shows up one time and it's in the users table, if rides had another name, so say like there was a rides name column, like just the name that the theme park assigns for the ride, that would be an ambiguous column, and then you would have to declare which table it's coming from. But since name only shows up once and it only shows up in the users table, SQL is going to be smart enough to pick that apart and know what you're trying to call. So now we're going to try to do this with a right join, and all we're going to have to do for that is just flip a few things. So we're going to right join and then do users here and then rides here. So what this is saying is we're going to use this column as our one that we're going to use all IDs for, instead of using the rides column, well, the rides table as what all is going to be returned. So again, this is just going to run the exact same. And it really doesn't matter how you want to do that, just whatever makes sense in your mind. So in this case, this would be the left table and this would be the right table. So if you have those two tables beside each other, you're just picking which one you're going to look at as like the main data set that you're going to be pulling from. So just whichever one makes sense to you. I normally like to use left joins just because I think traditionally read like left to right. So the main table would be the left table in my mind, and the other table will be your right table. But this is completely up to you and up to preference. So you can pick whichever one works for you. They all work the exact same. And I'm just going to change this back to how I would normally write it. We're going to run this. And then I'm also going to show you that you do have to have this descending character here, because if you don't, it will sort it in ascending. And we'll see that here. We'll see that we returned, well, all the travel distance is backwards. So Lee was first, Elvis also second. They had both 450, but we're see that our table is just reversed from what was expected. So that's why you have to put descending here. Now we'll run this again, and it's back to working. And then also, you can be a little redundant and put ascending here. It's not needed because the default is ascending, but again, it will run the exact same. So this was my solution to Leetcode problem number 1407, Top Travelers. If you found this helpful, please leave it a like and subscribe so that you'll not miss any more solutions moving forward. If you were to solve this problem in a different manner or would like to suggest a solution, please leave that in the comments below and I'll definitely get back to you. Thank you for joining me today, and I'll see you in the next one.